Hi, I'm going to give you guys an overview of Sprite Factory for Unity. So Sprite Factory is a 2D animation system for Unity that lets you create 2D games in Unity without having to manage things like atlases and all that kind of stuff manually. It'll handle all that for you. And it's got a lot of great features that should make it easier for you guys to make 2D games. Let's just go over a little bit of how the program works and what it does. So I'm just going to open up a little scene here that I made. It's got two characters standing here in the scene. So basically, if I press play here, you'll see that these characters are animating. I can make them walk, I can make them punch, I can even make him hit the other guy. All that is done with Sprite Factory. On the base of it, Sprite Factory allows you to animate frames and create an animated sprite, but it also includes some powerful features like a built-in box collider collision system and a locator system for attaching objects to sprites. It also even allows you to flip the sprite without having to do any kind of messing with normals or all that kind of stuff. But just to show you basically how it works, I'm going to go over to the scene mode, and you'll see these two guys standing here. They're each made up of a plane. So you see this internal blue frame here around the guy. That's the sprite plane. That's the main plane of the object. And if I look at the back, you can see it's just a one-sided polygon. That's all it is. It's a two-polygon quad. And the way the animation works is these characters, their frames are laid out onto one or more atlas texture sheets. And every time the scene updates, it will redraw the plane here. It'll basically move the vertices, the corners of the plane, to match what is happening in the 2D frame. So that's basically how the basis of the 2D animation system works. And then on top of this, you'll see there's a couple of other things going on here. This character has a couple of colliders. He's got a hit collider. This is a standard Unity collider with a rigid body on it, and it allows the character to detect being hit. He's also got an attack trigger, which is just another rigid body collider, which is set to trigger. That's invisible right now because he's not punching. When he punches, this attack trigger would be enabled, and it will be animated with the sprite so that you can have accurate collisions with like punches, kicks, bullets, whatever you wanted to use this for. He's also got a locator, which, as you can see, it's the pivot is right there in front of his hands, and that the locator system in Sprite Factory allows you to basically attach any object to a sprite at a specific point on that sprite and animate that point as the sprite animates. So if I go back to the game mode, I'm going to show you this guy can punch the other guy, and he's reacting. And that's just a very simple thing going on, but it's all built into Sprite Factory that allows this character, see this box where his hand is, this box is the hit collider, and this box is colliding with this character's, well, actually it's the attack trigger is what I should call it. This little box is the attack trigger on the guy's punching fist, and it's hitting this collider on the other character called the hit collider, and then there's a little script on this character that handles detecting that hit and saying what to do with it. Oh, let's play this get hit animation. But the colliders that are happening here, the animation of the collider as the guy punches, that's all handled by Sprite Factory. So if I split this, you can see a little bit what's going on. So this guy's going to punch, and you can see this collider is turning on and off when the punch is out, but it's not on when the punch is in. And that the shape can animate too. It just happens it doesn't need to animate in this instance. But that punch box allows you to do things like like this. So anyway, Sprite Factory has a centralized interface. So you get to the main editing interface right here from the window menu. So you see Sprite Factory. It'll bring up this editor window. And this editor window is the center of Sprite Factory. I mean, this is where you do everything. This is where you create your sprites. This is where you define animations. This is where you set up the colliders for the built-in collision system, locators. You can even do some rudimentary animation in here, position-based animation. Okay, so we have a number of things here which will be explained in another, in detail later in another video. But you can also check the documentation and see under using the editor. There's a big section on how the editor works, and it's got a lot of details going on. So that'll be the place to go for understanding how the editor works. I'll just go over it really quickly here. So what you have here is your list of sprite groups and your master sprites. So sprite groups is a number of sprites that are grouped together that will all share an atlas, or any number of atlases. That's the easiest way to think of it. So a master sprite is basically a template for a sprite. A sprite in the scene, such as this dude, will load its master sprite on awake. So when you start playing or when you instantiate the sprite, it will load data from the on-disk master sprite and create all the components of the sprite, such as the colliders if you have any, the locators if you have any. It will create the sprite planes. You can see your list of master sprites right here. So if I click on this, first of all, we're in this sprite group. You have to choose a sprite group, and by default there's one group called none, which is ungrouped sprites. So these sprites exist individually. They exist with their own, they get their own atlases and their own material sets, unique to that sprite, not shared with other sprites. So this is something you'll have to think about when you're planning your game. Should this sprite be in a group or not? I mean, you can always move them in and out of groups at will, and everything will be handled for you. The atlases will be recreated, all the material sets will be recreated, all of that. But if a sprite is in a group, like we have some right here, this background's T. You see this number 6. There's 6 sprites in this group. You can see the group properties here. You look at the master sprites in that group. We have a cloud, we have a tree, we have a flower, a small flower, a yellow one, a purple one. We have some hills. So this is a group, and this group of sprites will share an atlas or multiple atlases if necessary. Depends on how big the sprites are and the current atlas size setting. If I look in the saved data here, I can see the atlases for this group. That's sprite group 0, atlas 0. If you look here, you can see that this, let me open this in Photoshop. You can see that this sprite group atlas is just each sprite laid out onto a sheet. Just zoom in, look at it. So we've got our flower, our tree, our hills, cloud, a couple of other flowers. If we were to fill this sheet up, it would grow to a bigger size, up to 4096 by 4096, and then it would split itself onto another atlas sheet, and as many times as you need. So you could have as many sprites in this group as you wanted. And the advantage of a group basically is that they share atlases, they share materials, so therefore they reduce draw calls. If you have 10 trees on the screen, or tree and 10 flowers and hills and all that, that could potentially be one draw call because they're all sharing the same material. So that's the main use for a sprite group. But for now, we're just going to go deal with this individual sprite, this main character. I'm going to show you a little bit about the interface here. So when you click on a master sprite, you have all the sprite properties show up here. So you got his name, whether or not he's a static sprite. So Sprite Factory supports static sprites with no animation, which is useful for like a tree. A non-animated tree. So this tree is a static sprite. You can see it has one animation and one frame. It saves some time in the processing of the sprite. When you, if it has no animation, set it to static. Okay, so back to the dude. We've got, he's currently, you can change your sprite group. He's not in any sprite groups here. I could put him in one, but it would have to rebuild the atlas for that group. To create sprites how you need them, there you can add as many animations as you want. So here's a list of all the characters' animations. You can see it has a real-time preview of the animation. It shows, you know, this punch happening, shows what happens when he gets hit, shows him standing, and so this is useful. You can reorder, you can create new animations really easily. You can change animation frames, you can reorder them, you can add new frames in, you can delete them, duplicate them, anything you need to make your animation. You've got, for each animation, you've got properties for that animation. It's got a name, and this name's important because you'll call this in scripting to make the animation play. You've got wrap mode. These are the standard type of wrap modes. You loop and he'll punch forever. Clamp will stick there and just stay in that pose forever in the game, but I have it, it loops itself after like 3 or 4 seconds in the editor just so you can see what's happening. But ping pong, all these types of wrap modes. Anyway, you can set the frame rate for that individual animation. So if you want the frame rate to be faster, you can see he punches really fast. Want to make it really slow, slow it down. And along with that frame rate for that animation, you can see the frame properties. So each frame you click on has its own frame properties. You see how long the frame is being shown. This is 0.06667 seconds. So frame hold here determines how long a particular frame is displayed, how many frames it's displayed for before it ends. So like this can be useful if you need like the end of a punch to last longer. So like if you want this punch frame to hold out longer, you could set a frame hold of 3 on it. So it's going to hold that frame for 3 frames at 15 frames per second. So a total duration of 0.2 seconds. So you can see during the punch, his punch holds out longer. If I set it even longer, okay, so that's what frame hold is. You can even add an event here on a specific frame. When a frame plays, you can have a named event that you can then use in scripting. You can detect that event and make something happen. I mean, anything you can think of, you could use that for. But another nice feature of the Sprite Factory editor is this frame editor here. This gives you a real-time preview of your current frame of animation, but it's also got other uses. Like it has a light box, so you can choose another animation, like say a walk, and pick a frame of that walk and use that frame of that walk to, in the background, that little light box ghosted version of it, you can use that to help line up frames. If all your frames, you know, are different sizes, shapes, whatever, you might need to line them up in the editor. So you can do that easily. You can use the keyboard to move it up and down individual pixels. You can move it up here with the number, or you can just click and drag the character around, and you can line it up like that. Very useful. It also, aside from the light box, it also supports, allows you to edit colliders. So the collider system in Sprite Factory allows you to create any number of named colliders with all the properties that you could edit in Unity, like whether or not it's uses a rigid body, all the settings of a rigid body, whether it's a trigger. You can set the layer for that collider object in case you want to use layer-based collisions and such. You can choose whether that collider is animated or static. And so you will, when you're animating colliders, like say you were going to make this guy punch, and you want a collider there to be there when his hand is out, so you can detect a hit. The other guy he's punching can detect, oh, I've been hit. So we set up a collider called attack trigger, and you can see on attack trigger we've got this little purple box, and this purple box represents that collider for that frame, and it will be animated when the sprite animates. So you see all these collider frame properties appeared right here. So you see you can change it with these numbers. You can change it whether or not it's enabled or disabled in that frame, but you can also change the size very easily by dragging the corner points on this collider. You can even copy and paste the properties from one frame to another. So I just copied that so that those two frames have the same size box. And in frame 4, so in frame 0 it's not there, 1 it's not there, 2 it appears and it animates, and then 4 it goes away. I mean, you could easily make it, say I want to paste that there, so now in frame 4 we've got this big box. Well, we could pull it back. So now it'll still, when he's pulling back from the punch, it could still hit, but it would just be a smaller hitbox. That may not be useful there, but that could be used for all sorts of other purposes. And then another great feature of Sprite Factory is locators. So a locator is simply a transform, really. It's a transform with a name, and you can choose a color, and you can have as many of these as you want. And what it does, we edit locators right here under locator frame properties. Choose the locator you want to edit. So you can see there's nothing showing up here because the locator in this frame is not enabled. So we'll enable the locator, and you see this little green arrow appear. This green arrow is basic. It represents where the transform will show up on the sprite as he's animating. So in punch frame 0, we have the locator right here. I grab the locator and put it on his hand. Okay. Next frame, there's no locator. I can enable it, but it appears down there again. Or I could just copy this and paste this to all. I'm going to paste that locator frame over all the frames in this current animation. So now all the punch frames have a locator on them. Locator's in the wrong place, so we can adjust that. Let's take frame 1, we'll move the locator back to his hand. Frame 2, move the locator back to his hand. Frame 3, just center it there. 4, 5. So now as I walk through these animations, you can see the locator moves with him. You can also rotate the locator between frames. If I want this locator to rotate, first it starts out angled, then it rotates with his arm basically. And we'll just continue doing that for each frame. So now we have this transform that follows along a specific point on the sprite. So you say, what is this useful for? Well, there's a lot of things you could use it for, but one of the easiest examples would be a bullet origin point for a gun. Say you had a character that had like a gun arm, or he's holding a gun, and you want a muzzle flash to appear where the bullet comes out. You want the bullet to spawn where that bullet should come out at the barrel of the gun. You could put a locator there. Put a locator there, and then in scripting, get the position of the locator, get the rotation of the locator, and that could be used to instantiate your bullet. You could also use a locator to attach things to a sprite. You could put a hat on this character by putting a locator on his head and make it animate with him as he moves and stuff, and then the hat sprite could stay on his head. There's some issues you might run into using locators for things like that. Like say if you want to put a gun in his hand with a locator, you can do it, but there would be some issues. Like if he were walking, well, if he's swinging his arms. Let's say I don't have any arms swinging. Well, let's just show you this. I'm going to add a new animation. Call it run. Grab my sprite frames and find my run frames. Okay, so here, this is how you add an animation. Simple as this. Get your run frames. I got 12 run frames here. Drag them in. Boom. So now we have an animation called run. You can see he's stopping. So we need to set this to loop. Alright, see that? Now it's as easy as that. You made a run animation. He's running. If you want to run a little bit faster, set it to 20 frames per second. Now he runs 20 frames per second. So what I was going to show you is if you were to put a locator in his hand on a run, if you wanted to attach a gun here, like a gun sprite, you could do it, but you might run into some issues uh, when you got down to, the gun gets over here. Just put the locator there. If you imagine the gun would be in his hand, but it wouldn't know. It would be trying to draw the gun behind his body because this sprite is one object. So you have to be careful if you're gonna do that. You can set on the locator an offset for where the sprite is attached, where the transform appears in front or behind the sprite plane, and that could allow you to put the gun in front of the character the whole time. But you're gonna have trouble if you need some situation where the gun has to be in front of the guy's torso but behind the arm. I mean, you would have to have basically a multi-part sprite to do that. But anyway, so I've made these changes to the sprite, and you can see down here it's asking me, do I want to save my changes or revert? So this is a really nice feature. You can just revert, say revert, yes, I want to revert, and you'll go back to the original master sprite. No changes made. It's all back to the way it was. You didn't screw anything up. That's very, very useful. But if you did say you wanted to add that run animation, we'll just put them back. Boom. Set it to loop. 20 frames per second. Save. Okay, so this master sprite is saved. All the atlases have been rebuilt. So this sprite now has a run animation that you can call by scripting. So a couple more things about the editor here. We have under frame properties, we have offsets. We have the ability to offset the sprite on all frames or just one frame, in addition to offsetting the colliders and locators at the same time if we so choose. So if we were to want to realign this run so that he's running on this horizontal yellow line here, which represents the 0 on Y, so that the base of the sprite would be where the pivot is on 0, 0. We could move each of these frames up one by one, which would be a pain, or we could select this offset all frames here and move him up, and now all the frames on that animation have been moved up. But if we look at the colliders, you can see the collider was not moved with him. So let's go back, and if we want to offset the colliders at the same time, check offset all frames, also check colliders. Now if you want to offset static colliders in addition to animated colliders, you have to select static. You might have a purpose for offsetting just the animated colliders. But if you check static colliders will move too. Locators as well will move if you check offset locators. So now we can move the sprite up, and now he's been offset in all frames for this animation, as well as the collider has been offset, and locators, if there were any, would also have been offset. Another thing I should mention is material sets. Sprite Factory allows you to create any number of material sets for a sprite. What a material set is a material which a sprite can switch to at any time during playback. So you can have different shaders for different effects, different reasons you might want to display the sprite with a different material. You can set them up here beforehand and switch to them during the game. And if you have multiple instances of that sprite using the same material set, they can all be batched together. Now this up here is the editor properties. Let's just not save that there. Okay. Editor properties are global settings for all your sprites in the system. You might need to change some things like atlas settings or the global scale of the sprites in here. So when you change some of these properties, they might require rebuilding all of the atlases for all the sprites that you've created, which can take a lot of time if you have a lot of sprites. So it's best if you set these settings beforehand. You already know what your scale is going to be and what your max atlas size is going to be, etc. Set these settings beforehand and then start creating your sprites. You can change it at any time, but it can take a long time to rebuild. So there's a lot of options here, like the max atlas size allows you to choose the maximum size for an atlas file. You can choose to whether or not to trim empty space around the sprite so it saves space on your atlas sheet, saves memory. You can have a frame padding around the trimmed sprite so you don't get bleed problems. You can choose whether to compress textures or create maps for the atlases. And also you have a global pixels per unit setting here, which just means how many pixels corresponds to one Unity unit. So right now it's set to 100 pixels equals one Unity unit. So when a sprite is created in the world, it will be created at that scale so that 100 pixels fills the space of one Unity unit. This might be important if you're using physics. You need to have your scale set to something reasonable. Now, these settings here, the default settings, these just apply to new sprites or groups. When you create a new sprite or group, you can have it automatically set a default texture filter mode for atlases, ANISO level, or whether or not you want a two-sided mesh for that sprite. When you make changes to these settings, it doesn't have to rebuild anything, so you're good. And then this area here, these buttons are controls to help you do things like create sprites in the scene or rebuild a master sprite if you need to fix a problem or you've made some changes, you want to update that sprite, resave it, you can rebuild it. There's also some bulk utilities for rebuilding all the atlases at the same time or rebuilding all materials, or even to check if any atlases need updating if you've changed any source images on the disk. And then of course we have save and revert down here. So let me show you how you create a sprite from this master sprite in your scene. So this master sprite exists as a template on disk, but we also need a sprite in the scene which we can use in the game, and we can create prefabs from it or whatever you want to do with it. So select your master sprite and click create sprite in scene right here. Let's close the editor. That will create a third dude right here in the middle, and this is the new sprite we've just created. You can see in the inspector it has all the components a sprite needs to have. It has a mesh render, mesh filter, sprite component, and the material and the atlas have already been automatically assigned for you. So you can create a prefab from this character here, but you don't have to. It's up to you. Sprite Factory will work just as well with prefabs or non-prefabs. There's really no difference. So let's get rid of this new sprite. So the settings we were changing in the Sprite Factory editor applied to all the sprites based on a master sprite. Well, each sprite also has its own settings which you can set for individual instances of that sprite. Those you can see in the inspector here. There are things like animation, material settings, other things like that. So let's just look at a few of these quickly and see what they do. So we've got this play animation on start. I'm going to look at the animation settings first because they're a little more straightforward. The main settings are pretty complicated, and I'll go through those in a minute, but let's just look at animation settings first. So we have play animation on start. These are very similar to the way Unity's animation system works. So if you play an animation on start, that means whatever his default animation is, which was set in the editor there, the default animation will play when the sprite is instanced or when gameplay begins. Play default anim when idle means whenever an animation is no longer playing, play that default animation again. So in this guy's case, his stand animation is his default animation. So whenever he's done animating, like say after a punch, he'll go back to playing the stand because play default anim when idle is set. Let's just play this here. We've also got playback speed. So playback speed is a way you can change the speed of the sprite animation globally for that instance. And you can see now he's moving up and down really quickly because I changed the speed. This will affect all of his animations. So if he were to walk, he would be walking fast. If he were to punch, he would be punching fast. There are also settings you can change via scripting for where you can change the speed of the individual animation. So you can make him punch faster one time, make him punch slower another time. It depends. You can set all of that as you will. That can be useful for changing the walk speed. Like say you want him to walk slowly when the player presses lightly on the joystick controller, or make him walk faster when the player presses harder on the joystick. You can do all that by changing the speed of the individual animations. But this playback speed setting here affects all animations in the sprite. So we also have animate off camera. This allows the sprite to continue animating when it's not seen by any camera. If you want to disable this, he'll stop animating when he goes off camera, saving a few processing cycles. It's not that big a deal, but there might be some reason you might want to stop the animation off camera. Default animation override is a setting that allows you to change the default animation for that specific instance of a sprite. So right now the master sprite is set to use stand as the default animation, but if we want this instance to use run as the default animation, we can set it right here, press play, and he now runs as his default animation. So then we got right here the drop down that shows you what animations exist in this sprite. This is just for your reference so you can remember the names of the animations and use them in your scripting. Then we have material settings here, and the first one is material set. So material set, as I mentioned earlier, is a it allows you to create materials for this sprite and switch to them on the fly. And let me just show you how that works. It'll be more clear. This sprite currently has two material sets, which I set up before in the editor. Let's go show you that. So if you click material sets, you can see it has the default material set, which is just the regular sprite material, default sprite material that it comes with. And then I created a test material set. And this test material set is using a material I created called test right here in the project. So the test material is just I used a particle shader. So you need to use a material that has a underscore main text property, which will have the atlas will be assigned to that main text property. So any of Unity's shaders will be fine for that. They all have a main text property as far as I'm aware. And so I just chose the particle additive shader for just for this example and changed the tint color to red so you could see something's happening. And I dragged this test material I created onto the source material for that material set. And then so now the sprite has two material sets. One is the default skin and the other is this test shader. So if I go and choose that sprite, go back down here and select test as the material set, you can see nothing happened. Well, it can't show you the material set change in the editor, but when the game is playing, you will see the material set is different. So right now the material set is set to test, and it's using a particle additive shader. You can see this character is semi-transparent red. If I change material set back to default, you can see he went back to his old material. So the advantage of material sets are you can have, let's disable this sprite just for a second. So the advantage of material sets is you can have multiple copies of this sprite, and as long as they're all using the same material set, they will be able to be batched together. So you can see these three characters have one draw call. They're batched together because they're sharing the same material on disk. There's not been any instancing of materials happening here. If I were to change these characters to default, to characters material set to default, you can see now we have two draw calls. one draw call for this guy, for the guy on the left, and one draw call for the two guys on the right. We go and we change all of them back to default material. Now we still have two draw calls. Now we have one draw call. So that's nice. Now if we were to not use material sets and instead apply a material directly to these characters, which you can, you will not have that advantage of draw calls. But you have the ability with this other option here, material override. This allows you to apply a material at any time to a sprite. Any material, as long as it has a main text property, you can apply it to the sprite and it will create the right materials from it and apply the atlases. And this is useful if you have, like, say you have many different sprites that you want to apply the same material to for some effect, and you don't want to go and predefine those material sets for all those sprites. You just want to apply that material and have everything display that material, and you're not really concerned about the extra draw calls that will be incurred, because when you apply a material through material override, the material is instanced for each instance of the sprite. So if I were to apply this test material to this sprite, and apply this test material to this sprite, and apply the test material to this sprite, and press play, they will display correctly, but you will notice we have three draw calls. They can't be batched together because it's creating an instance of that sprite in memory, an instance of that material in memory for each sprite instance. So it can be convenient if you have an effect you need to apply to lots of different sprites and you don't want to predefine the material sets, but it will take more draw calls if you have multiple instances of that sprite on the screen. So in general, if you can use material sets, you probably should, because it'll save draw calls, which are, important for cell phones and such. So let's get rid of these other copies of the guy and go OK. So here we see we've gone over the animation settings and the material settings. Let's look at the main settings now. So we have one setting called self-update. Self-update means the sprite will run its own animation update cycle. The Sprite script has an update function which will run all the animation to make the sprite update every frame. Now that may or may not be desirable. You may have some need to update the sprite on your own timing, or update the sprite in another update cycle, like fixed update or late update. You might want to be able to pause the updates of the sprite. So if you need any of that functionality, you should disable self-update in the sprite and add a SpriteUpdater to the scene. So in Sprite Factory, under prefabs, there's an object called SpriteUpdater. Let's drag that into the scene, and we get this SpriteUpdater that appeared, and it is responsible for updating any sprites that are assigned to it on whatever cycle you choose. So you can choose the update cycle for this SpriteUpdater here. Tell it, do you want to update in the update loop, or the fix update loop, the late update, or manual. Manual means it doesn't update until you call an update function manually on the SpriteUpdater. For now, we'll just try the update cycle. We'll go back to the sprite, and you need to assign the updater to the sprite. So this field here, SpriteUpdater, let's drag the SpriteUpdater into this field, and now that SpriteUpdater will be updating this sprite. If I press play, he updates. If I take this updater out of this field, he doesn't update anymore. He's no longer animating. So, okay, the next option is Billboard. This is useful for if you have a effect sprite. You need it to be a billboard polygon that faces the camera all the time. Enable this. You also have a billboard up axis, which is a hint up vector that it will try to align the sprite's y-axis to this axis, whether it's on the world, or you can also choose to align it to a camera axis. So then So here's another option. Here's another important feature called use batch scaling. So use batch scaling allows you to scale multiple instances of a sprite but not waste draw calls. So if you enable use batch scaling, it will scale the sprite using the mesh itself. It'll change the vertices of the mesh, and it'll also scale any colliders or locators that you've added through Sprite Factory, so that you can have sprites of different scales on the screen and be able to batch those together as one draw call. So I can show you that here. If we copy this guy a few times and we scale him, scale each copy of him a little bit. So we have 3 copies of the guy. We press play. We see we have 3 draw calls. Each of these guys is the same, and he should be batched together, but Unity will not batch scaled objects. So if we were to go enable use batch scaling on each of these guys, it will take this transform scale which you've set, and it'll convert that to a mesh scale and a collider and locator scale that don't rely on the transform. So these transforms will go back to 111, but the sprites will stay the same size. You press play, the sprites all stayed the same size relative to each other, and their transforms all say 111. Well, draw calls 1, batch 3. These guys are all batched together. So that can be extremely useful, especially for things like backgrounds and stuff like that. Like if I open this other scene here that I have, you can see this scene is made up of a bunch of different parts. There's 4 sky meshes, some clouds. They're all instances of each other that are scaled different sizes. We have some tiling hills, trees. All these flowers are just scaled versions of each other. If I press play, this is only 2 draw calls, because all of these flowers, all of these clouds, they've all got use batch scaling set. And so they're able to batch all this into 2 draw calls, which is very nice, very useful for cell phones and tablets. Let's go back to our fight scene here. Turn off my other guy. So let's look at the other options here. We have scale to actual pixel size. This option would make the sprite actually scale so that 1 pixel on the sprite equals 1 pixel on the screen. And this is probably not what you want to use most of the time. This option is there if you need it, but for most people, this would not be a good option to use on all your sprites, because while it scales the sprite itself, but other things in the scene will not be scaled, like the distances between objects would not scale. Just because the sprite scaled, the distances between objects wouldn't scale. So that would mean physics would be different. A lot of gameplay logic would be different if you were to rely on this. What you probably want instead of scale to actual pixel size for most cases would be to make the camera render everything at their actual pixel size. So to do that, there's a sprite camera right here in the prefabs, which has a sprite camera script on it, and you can add that to the scene. And this, I already have one in the scene, but this would allow you to enable render at actual pixel size. This will change the camera's orthographic size settings so that the sprites would be rendered at 1 pixel in the sprite equals 1 pixel on the screen. Right now it's already set to that. I can show you what it does by changing this scale. So I'm going to zoom it way back. So if we look at game view, let's just zoom it way back. That guy's tiny, right? So if I were to click this render at actual pixel size, it'll find the right orthographic size for the camera that will show this sprite at the actual 1-to-1 pixel size on the screen. This is more useful for most people. This is probably what you're expecting to use to get your whole game to display at actual pixel size. I want to mention a little bit about the sprite class quickly, just so you get an idea of how it works. The Sprite class is the main Sprite class for Sprite Factory. And you will interface with the Sprite class to play animation or do other things. You can see this is the class here in Visual Studio. And if you look at public animation controls, you'll see these are all the functions you have to play animations, play at a specific frame of an animation, play the default animation, stop animation, pause animation with an optional time to pause for. You can unpause, you can rewind animation, you can query whether animation is playing a specific animation by name or index. You can get the animation speed of a specific animation by name or index. You can set the animation speed of an animation by name or index. You can do there are other public controls here, such as setting material overrides, enabling disable material overrides, changing the material set on the sprite. You can get a list of all the internal colliders and the rigid bodies that are being created by Sprite Factory. You can get locators and list of you can get a specific locator by ID or name, so you can do things with that locator, such as get the position, the rotation, attach objects to locator. You can flip the sprite on X or Y or both axes. You can scale the sprite to actual pixel size, ignore collisions. You can set active recursively, which will basically disable all objects below the parent sprite, and it'll be correctly handled with all the subparts of the sprite will react correctly. You can change the use batch scaling state. You can also get some other information from the sprite, such as the animation names, the material set names, the animation frame counts, collider names, things like that. So this makes it really easy to control your sprite through scripting. So if we look over at this file called sfdemoplayer, this was the script that was on the player on the left side, the dude on the left side of the screen who was walking around and punching the other guy. This is a very simple script, and it's a little bit oversimplified, especially in the input part, because we're just using direct keyboard keys instead of using joystick axes. But that's not the important part. The important part is right here. The actual playing of animation is as simple as sprite.play and the name of the animation, stand. Sprite.play walk. Very simple. You can so sprite.play punch right here. It's very similar to the way Unity's animation system works, and you can tell it whether or not you want to replay the animation when you play it from the beginning. So if your punch needs to interrupt the previous punch, you can set the Boolean true here, replay from start, and that will always interrupt the punch and replay the animation from the start. If you don't do that, then it'll just continue playing if it's already playing. You can see how easy it is to tell whether an animation is playing. Sprite.isAnimationPlaying playing punch. Very simple. So there are also some properties in the SF Sprite class that allow you to get a lot of data about what's happening with the sprite, such as whether it's is it a static sprite? Is it active currently? Is it playing any animation? Is it paused? Is it visible? Is it flipped in either axis? How many animations do you have? How many material sets do you have? How many colliders do you have? How many locators do you have? The bounds of the mesh. This is the bounds of the actual current mesh that's being displayed of the sprite. So, like, the plane. And some sprites may have multiple mesh planes because they have more animation than can fit on a single atlas. So it builds multiple display planes under that sprite and switches to the correct one at the right time during an animation. This bounds will return the correct bounds for whatever animation is currently displayed, even if it's off screen. You can get the name of the currently currently playing animation, or you can get the index of the current animation. You can get the current frame index if you need to know exactly which frame you're on. You can set the batch scale for the sprite, so it allows you to scale the sprite at any point. There's other properties such as the default animation. This tells you what the name of the current default animation is, or the index of the current default animation. You can see current animation speed, the playback speed of the currently playing animation. There's a lot of functions and properties here that will help you animate your sprites very easily and get information back from the sprite to do all kinds of things that you might want to do. So I just want to show you the documentation really quickly on Sprite. We have under runtime classes, here are the main runtime classes. So the main one is Sprite. This has it's very, got detailed documentation just like Unity's documentation on each of the variables, properties, functions, all of the things you can do with it. You can click on it and get help for what you're interested in. So I hope that gives you a good overview of what Sprite Factory can do. There are some things I did not go over, but you can find some additional help in the documentation. You can find also there will be more videos like this one on specific topics available. I hope you're able to get a good taste of what Sprite Factory can do and determine whether or not it would be the right choice for your project. So thanks for watching.